Hello everyone, welcome back to the online session on Computer Aided Engineering Drawing. I am Professor Abhishek Gowda from the Department of Mechanical Engineering, M3IS2. In the previous session, we have learnt about the introduction to the isometric projections, and also we solved two problems on isometric. In continuation to that, in today's session, we are going to solve few more problems on the isometric projections. Let us see problem number 3. The frustum of a square pyramid of sides 40 mm and height 60 mm rests on the center of the top of the square block of sides 60 mm and height 20 mm. The base edges of the pyramid are parallel to the top of the block. Draw the isometric projection. This is the problem statement. As I said in the previous session, we need to be very conscious about the problem statement. See here, the frustum of a square pyramid. Okay, first of all, we need to imagine how a square pyramid will look. Okay, if we able to imagine that square pyramid, means it is very easy to draw the frustum of pyramid. Okay, so always when we say the word frustum, means it will be like cut off section of the top side, the frustum of the square pyramid. So here that square pyramid of the sides is 40 mm and height is 60 mm. I mean the square pyramid sides are 40 mm dimension and the height of the square pyramid is 60 mm dimension. Rest on the center of the top of the square block. There will be a square block and in that it is resting on the top side, and that square block of the sides 60 mm and height 20 mm. The sides of the square block will be 60 mm and the height of that square block will be 20 mm. This is the given problem statement, and for this we need to draw the isometric projection. As we know, we have to draw the front view and top view for this problem first. So I'll draw the front view first. Okay, now we need to take a reference XY line. Okay. Now the square block of the sides is 60 mm and 20 mm. So first we need to start with the square block. So when we see a square square block from the front side, it will be in the form of rectangle only. 60 mm, the height of that, the base sides of that square block, and the height will be 20 mm. So the sides length will be 60. This is 60 and this will be 20. Okay. Now the base edge of the square pyramid is 40 mm, height is 60 mm, and the missing data, that is the top side of the frustum, will be 20 mm. So the bottom side, the base side of the pyramid is 40 mm. So this is a 60 mm line. So you can take a midpoint here, and from this 20 mm towards left hand side and 20 mm towards right hand side. And the height will be 60 mm. The side is 40 mm, the height is 60 mm. The top side of the frustum will be 20 mm. So from this midpoint, 10 mm left hand side, 10 mm right hand side. So we can plot a 10 mm, 20 mm line here. Okay. Now you can join this to 40 mm point. So the height will be, this is 60 and this will be 40 and this will be 20. Okay, the height of the square pyramid is 60, the base side is 40, top side of the frustum of the square pyramid is 20. So now let us draw axis line here. Okay, so front view is completed. This is an XY reference line. So from this we have drawn the square block of the side 60 mm, 20 mm, then square pyramid, frustum of square pyramid of dimensions 60 mm height, 40 mm base sides and top side is 20 mm. Now I'll just extend these lines for the top view. Okay, so now we need to draw the top view. Okay, now from the top view, just imagine when we see it from the top view, it will be look in the form of a square area, a 60 mm square block, again within that a 40 mm of the square block of the frustum of square pyramid, and again within that 20 mm top side of the square pyramid block. So it will be almost in the form of square only. Okay, so this is 60, this is 40 and this is 20. So this is how top view can draw. A 60 mm square block, 40 mm square block and one more 20 mm. Why it is so? 60 mm square block is the base of the square block. And this one 40 and 20 are the base sides of the frustum of the square pyramid. Bottom side 40 and top side 20 mm. So this is how we'll draw the front view and top view. Now we'll draw isometric projection for this problem. According to this problem, we need to start with the square block of side 60 mm and height 20 mm. So let us consider a reference line of XY. Okay, now we need to, I need to measure 30 degree here because you already have the printed page, but here I don't have it. So let us mark this as 30 degree and here it is also 30 degree. Okay, now with respect to this I need to draw the 60 mm line. 6 boxes I need to count. Towards right hand side as well as in the towards left hand side. Okay. In your sketchbook 60 mm toward right hand side means 6 boxes. 1, 2, 3, 4, 5, 6. 6 boxes. That will be count as a ISO 60 mm. And what is the height here? 20 mm. Height is 20 mm. Now join this. You should use scale protractor properly, otherwise you will not get the exact dimension. Now again from this I need to draw the 60 mm line to make it as a square block. Now again from here close this. Okay, so here we'll get a midpoint. So this is 60 and this is 20. So in this area you need to mark the midpoint, a point on that area. Okay. Now what we have to do is, now we need to fix this square frustum of square pyramid. The base side is how much? 40 mm. So here we need to draw the 40 mm area first. Okay, this is the midpoint. 40 mm means towards, above the midpoint it should be 20 mm and below the midpoint it should be 20 mm. So just mark two boxes above the midpoint and in the same fashion below the midpoint. Okay, now just join this. Okay, now the 40 mm base side is ready. 40 mm base sides. So what we need to do now, the height of the square pyramid, that is 60 mm. So from this midpoint you need to measure 60 mm height. 60 mm height from the midpoint. Now the top area of the frustum will be 20 mm, no? So from this, again you need to create a 20 mm area. Above the midpoint 10 mm, below the midpoint 10 mm. One box above the midpoint, one box below the midpoint. Again here it is 30. Because otherwise I won't get proper shape here. Okay, now the 20 mm square area, the area of the square pyramid is ready. Now from this we need to join the bottom edge of the square pyramid. Okay, so now the pyramid is ready. And just for the appearance or the looking of this 3D wave, we can just extend this line here so that it will be like in the form of proper square pyramid, and we can rub this area. We don't want this. You can clearly see the square pyramid, frustum of square pyramid. This is a final touch-up just to show a 3D view of this particular problem. At last, you need to erase all unwanted lines, only you need to show the visible lines. Okay, so this is the final view of this problem. Frustum of a square pyramid, resting on the square block. Now we will see the next problem. Problem number 4. A pentagonal pyramid of base side 30 mm and axis length 60 mm is resting on HP on its base with the side of the base perpendicular to VP. Draw isometric projections. See, this is a different kind of problem compared to the previous 3 problems, because in all the 3 problems what we have solved previously, that is all like first we are going to draw the front view, then top view, then we'll move on to the isometric projections. But in this kind of problem, first we need to start with the top view, then we can continue with the front view, then we can draw the isometric projections. Why it is like this? So that is the beauty of this problem. By solving it, we'll get to know why we need to draw the top view first, then the front view. See, the problem is based on the pentagonal pyramid. So it is all about the pentagonal pyramid. We need to draw a pentagon of sides 30 mm first. Then we can proceed with the front view. So now I'll take a reference line of XY. Okay. Fine. Now I need to draw the top view first. Okay. So in the top view, what is the side? They have given 30 mm sides. So now I'll draw 30 mm pentagonal sides of pentagonal. Okay, now the side of 30 mm is done. So while constructing this pentagon, here I am going with the angle here. So from here I need to measure the 72 degree, and again from here it should be 72 degree, and in the inside angle it should be like 108 degree. And what is the side? That is 30 mm. So from here towards this angle it should be 30 degree. Got it? Either you can just draw a line of just a line towards 72 degree, then you can use your compass and you can cut an arc of 30 mm distance. You must be careful about the lines, because it should not be vary with the 0.1 centimeter also on your scale, otherwise we won't get proper pentagon. Now you can use your compass and you can measure this distance from here to here. It should be like so you need to measure here, and we need to cut an arc. Okay, and here also. Okay, so here we'll get the midpoint and just join this. Okay, now the pentagon is ready. Got it now? Now pentagon is completed. Now we can mention the midpoint for this pentagonal area. See here how for this base, this is the midpoint, opposite point, and for this is the opposite area. So for this, how much it is? 30 mm, no? So for this, just draw a line to show a midpoint in opposite direction. In same way here also. So once you get the midpoint here, this is how you will get a midpoint. Then just extend this line and from the midpoint, okay, just for our reference where we have taken these lines. So this is the top view. This is the top view. We need to draw the pentagon of sides 30 mm, then we need to find out the midpoint, then we can project the lines. So now what is the height of this pyramid? 60 mm axis length. So this is what the center axis for this pentagon. So from this we need to take a height of 60 mm axis length. Okay. Now here we have 3 points A, C and D, because B is the axis line. Don't get confused, there is a gap between axis line and the one more side, that is point C. Okay, axis line should not be overlap on the other line, because there will be a gap between the axis line and one more line if we draw the pentagon proper dimension. Draw the pentagon with proper dimension. Now just close this area from this to A. Next again from here to D, and again from here to C. Okay, so this is what the area of the pentagonal pyramid. So this is the front view. What is the height? This is 60. This is 60. So this is how we will draw top view and front view for the pentagonal pyramid problem. That is why I said for this kind of a problem, first we need to draw the front view, then we can draw the the front view. That is why I said for this kind of problem we need to draw the top view first, then we can extend it to front view. We can't directly draw front view as the first step, because we won't get the correct pentagon. So that is why first we need to draw the top side of the pentagon, then we can extend it to the front view. So now we'll plot the isometric projection for this problem. Okay, here also you should be very careful. On the isometric sheet it is very difficult to draw pentagonal pyramid. So what we will do is, we have already considered this one, the pentagon already constructed. So what I'll do is, I'll just draw a line to cover this pentagon. The entire pentagon should be covered within a square. So I'll just cover it by a lines. Okay. So within this square area, we have covered the pentagon here. Okay. Why do we want this square block here? We'll get the answer now. See here, we need to measure these distances. What distances? These distances and these distances. Okay, when we manage to find out these distances, what will be the distance from here to here and from here to here means, so within that square area we can measure the distances between the lines, where it has been started and where it has been ended. So using these dimensions we can plot the pentagon on the isometric sheet. See, now this sheet is in the form of square, right? I have covered this area within the square block, but our isometric sheets, the lines in that sheet will be arranged in the form of 30-degree orientation. What I'll do is, I'll just tilt this square block like this, in this way. Okay, I have covered the pentagon by the square block. Okay, now again that square has been like tilted to the 30-degree orientation. Why? Because this is printed on the isometric page, it should be lie on the 30-degree. So when this square is tilted like this with respect to 30-degree, now you can easily plot the pentagonal pyramid on the isometric page. I hope you got my point. You need to cover the pentagon in the top view and you need to measure the distances. Then with respect to that square area, you need to tilt that area towards isometric sheets. Okay, so now it is easy to draw the isometric projection. Okay, just consider this point. From this point I am just drawing the line. What is the square dimension here? First we need to measure this area. Okay, okay, and as usual, 30-degree direction. Okay, here 30-degree, once again I need to measure. So in your isometric sheet, the lines are aligned at 30-degree only, correct? No? So I have just tilted this square in 30-degree direction. Okay. Now I'll measure these dimensions. Okay. So from here, this is the first point here. First point. 1, 2, 3, 4. Again 1, 2, 3, 4. Got it? This is my first corner, second corner, third corner, fourth corner. In the same fashion. First, second, third, fourth. Okay. Now I'll measure from 1 to 2. 1 to 2. Measure these distances. So in the center it should be 30. In the sides it should be, you have to measure these distances. What is the side distances? It should be around 2.8 or 2.5 something. And here also the same thing. Okay, now 30 mm pentagon is drawn here. We have a separate sides over here, so that you need to be measured with the scale here and here. Got it? Okay. Now from this, again now from 2 to 3, 2 to 3. From 2 to 3, we have a separate line here. We need to again measure this line. We need to measure with your scale and again we have to mark it over here. Okay. Then here we have only two sides, this portion and this portion, that's it. Only two portions. So that is how I marked here. Okay. Now 3 to 4, again we have a separate two equal sections. We don't have uneven sections here, we have the equal section. So we can directly take the midpoint here. Okay, I have marked that. Next, again 4 to 1. 4 to 1 dimensions are different. From here to here it is different, and from midpoint to here it is different. Okay. Now all the points have been marked here. Got it? How we have marked here? Based on this top view. 1, 2, 3, 4. We have a square here. Within that we have a pentagon. Based on that I have marked the areas. Now I'll just join this to make it as a pentagonal area. See, we got the pentagon within that square only. The same pentagon within that square has been tilted to 30 degree. So we got the pentagonal area here. Okay, and also we have the midpoint here. See here. So here also we will get the midpoint. So what is the height of this pyramidal length, pentagonal pyramid length? This is 60 mm. From this midpoint, we need to plot a 60 mm axis length. Okay. Now 60 mm axis length is ready. Once the length is ready, the problem is simple. Just we need to join these lines from here to here, then again from here to here, then again from here to then again from here to here. And we have one more dimension here. Now we can rub the all unwanted lines. Now I'll just highlight this area so that the visibility will be clear. Okay. See, now the pentagonal pyramid is ready. This is the base of 30 mm side. Okay. Now clearly see the axis length, the all sides corners of the pentagonal pyramid. This is how we are going to draw the iso projections for the pentagonal pyramid. See, from the top view we have started and then we have proceeded with the front view. So using that condition we can plot the pentagonal pyramid.